Alright, here we go, iChem lesson number 15 on predicting products. Notice we're only going to work on predicting products of combustion, single replacement, and double replacement. I'm not going to ask you to do it for synthesis and decomposition reactions. They're a little bit more complicated and the pattern isn't quite as easy to figure out. What this means for these three types of reactions, though, is that from this point forward, I might only give you the reactants and not the products, and expect you to be able to write a whole reaction equation, including the products, based on the patterns and what you learn in this iChem lesson. So first, you should already be somewhat familiar with identifying the type of the reaction, looking at the reaction equation and deciding, is it synthesis, combustion, single replacement, double replacement, and so on. So now we're going to be doing the same thing, but we're really only going to be looking at the reactants. So when I'm talking about the pattern of each equation for combustion of hydrocarbons, if I only gave you the reactants, what you'd be looking for in the pattern is this: a hydrocarbon reacting with oxygen gas. That's the definition of a combustion reaction. Those are the easiest to predict the products. They are the same products every time. So every time you see this, you can automatically write this. Then just comes balancing. These ones tend to be the hardest to balance, but I gave you a hint with that. In balancing, we do carbons, then hydrogens, then oxygens for this one. Alright, single replacement of metals. We should recognize the pattern as one thing replacing another. Remember, in the definition, we recognize these as a single element paired with an ionic compound. That's what you're looking for. If you're given the the reactants, you write the reactants and identify, I have a single element, an ionic compound. This is going to be a single replacement, and I know based on the definition of a single replacement that the single element is going to replace its like element in the ionic compound. So metals replace metals. We're going to use something that's called the activity series with this. You'll get that tomorrow, so you don't even need to worry about it now, but you need to know that you will need it. There's also single replacement of halogens. Halogens are non-metals, so same idea, same recognition. I have a single element, it'll be a diatomic element in this case, and an ionic compound. When I recognize that single element, ionic compound, I know that the single element is going to replace its like element in the ionic compound. Non-metals replace non-metals. So Y replaces X, I end up with By and X2. Remembering the halogens are diatomic, so I will have any lone element will be a diatomic element. The last one is double replacement reaction. You recognize these by two ionic compounds. And what's going to happen is the ions will switch partners. So A will now partner with Y, and B will now partner with X. It's really important to remember this last part. These are both ionic compounds. When they form new ionic compounds, you need to write the ions and swap and drop to get the right answer. This is not going to go away. Alright, so here we have a combustion of hydrocarbon example. So you have a chemical equation for the combustion of carbon tetrahydride. Carbon tetrahydride is just carbon and 4 hydrogens. Okay, its combustion, I know that it's going to react with oxygen. Now this is a pattern I would recognize if it said carbon tetrachloride, tetrahydride reacting with oxygen gas. I would say, oh, that looks like a combustion reaction. I automatically know the product to be carbon dioxide and water. The last step would be to balance this equation. I have one carbon. I have 4 hydrogens. I only have 2 hydrogens over here. So if I put a 2 here, that takes care of that. And now on the right side, I have 2 oxygens plus 2 more oxygens. That's 4 oxygens. I need 4 oxygens over here. So you're never done until the equation is balanced. Next example, I have iron. So just, oh no, my pointer went away. Just iron reacting with nickel 2 chloride. It's an ionic compound, so I want to write my ions, nickel 2, chlorine, NiCl2. Now I look, I have a single element and an ionic compound. I identify that as a single replacement reaction. Like replaces like, so iron is going to replace the other metal, which is nickel. We would need to look at the activity series, kind of see here, to verify that it would happen. And the idea is that only things that are more active would replace. So iron is higher on the list than nickel. So iron could replace nickel, more reactive. So if nickel gets replaced, I have nickel off by itself. And then I have iron with chlorine. Now you have a couple of options here, because remember, iron can be a couple of different things. It could be iron 2+ or iron 3+. Let's just say you have iron 2+ and chlorine is still always 1-. I have FeCl2. Here's another example. I have chlorine reacting with strontium bromide. Chlorine, and keeps disappearing. Chlorine is Cl, and remember it's a diatomic, 2, reacting with strontium bromide. Strontium is Sr2+, and bromine minus. So this strontium bromide compound is SrBr2. Now I'm looking at this and I see a single element and an ionic compound. I identify that as a single replacement reaction. The chlorine will replace its like element in the ionic compound. It's not going to replace strontium. Chlorine is a non-metal, strontium's metal. It will replace bromine. Now again, we're looking at the activity series. Fluorine is more reactive than chlorine, is more reactive than bromine, is more reactive than iodine. You go in order on the periodic table. So chlorine is more reactive than bromine, so chlorine would react. I would have bromine off by itself, remembering that bromine is a diatomic molecule. And then I would have strontium and chlorine forming an ionic compound. Swap and drop, SrCl2. The last step would be to balance. I have 2 chlorines. I have 2 chlorines over here. Strontium, 1 strontium, 1 strontium, 2 bromines, 2 bromines. It's already balanced. I'm done. Alright, next one. Write the chemical equation for lithium dichromate reacting with aluminum nitrate. So lithium dichromate. Lithium is a metal, so So it would be an ionic compound, Li plus, and dichromate ends in 8, so it's a polyatomic ion. You find it on your sheet, Cr2O7, 2 minus. When I swap and drop, I end up with Li2, Cr2O7. Reacting with aluminum nitrate again, write my ions, Al3 plus, nitrate ends in 8, so it's a polyatomic ion, NO3 minus. Now I swap and drop, I end up with Al, NO3, with a 3 outside. I notice ionic compound tells me it's a double replacement reaction, so I know that my ions are going to switch partners. So I should have my ions already written up here on the top. Might help to draw arrows. Lithium now will be partnered with nitrogen, and aluminum will be partnered with dichromate. Always draw your arrows from cation to anion to help remind you that the cation goes first. So when I swap and drop, don't necessarily have to rewrite my ions, I'm just recombining them. If you already have them with the appropriate charges, it's okay to not write them again. I have lithium and nitrate. If I swap and drop, I end up with LiNO3. And then I have aluminum and chromate. Remember that I'm always writing my cation first, so I have aluminum. When I swap and drop, that 2 from dichromate ends up on aluminum, and then dichromate in parentheses, and that 3 on aluminum comes out here. The last part of this one is to balance it. Now, the thing about double replacement reactions is you have a lot of different elements going on in here, but really I just need to balance on my ions. So balance my dichromate and my nitrate ions separately. So I notice I have 2 lithiums over here. I want 2 over here. I put a 2 in as a coefficient. My lithiums are balanced. Now look at my chromate. I have 1 dichromate here, and I have 3 dichromates here. Uh-oh, that's going to mess up my lithiums, but it doesn't matter. Just commit. You'll fix it in a minute. Now I have 3 dichromates, and I have 6 lithiums. So what I really need is a 6 here. Now move on. Aluminums. I have 1 aluminum here. I have 2 aluminums over here. So if I put a 2 here, my aluminums are balanced. And now look at your nitrates. I have 3 nitrates in the compound, times 2 is 6, 6 nitrates. I have 6 nitrates over here. I'm balanced. This double replacement reaction is done.